Hi everyone. So today we are going to solve first 5 questions from paper 4-1 May June 2024. Question number 1. A long tube contains oil. A small ball is held at rest at the surface of the oil. At time t is equal to 0, the ball is released and begins to fall vertically through the oil. Figure 1.1 shows the ball falling through the oil. Alright, so it means that we are going to talk about some resistive forces here as well as we're talking about the oil. As the ball begins to fall through the oil, it accelerates, right? Define acceleration. So just need to write the definition for 1 mark. That's the rate of change of velocity, or we can say the change in velocity per unit time. B part. The ball has a mass of 0.0075 kg. Calculate the resultant force acting on the ball when it is accelerating downwards at 2.8 meter per second square. So we're talking about the acceleration. We have to find out the resultant force, and we know that this is F is equals to ma. Just need to substitute the values. You will get the required answer. So on calculating, we'll get 0.021 Newton. C part. As the ball falls, its speed v is recorded. The speed time graph for the falling ball is in the figure 1.2. We see that it's moving with a constant speed for some instant, then the acceleration is decreasing up to this instant, maybe here, and the object is moving with a constant zero acceleration here. Describe what happens to the acceleration between t is equal to 0 and t is equal to 0.040 seconds. Alright, so we have two parts here. What happens to the acceleration? Explain why this happens. For the 4 marks, we need to justify what is happening to the acceleration and why this is happening. We can see here that here the object is moving with a constant acceleration here in the start. Okay. Then acceleration is decreasing till some point here. Okay. And here it becomes a straight line, so the acceleration is 0 here. So first we need to talk about what's happening with acceleration. Acceleration is decreasing. Okay. So why this is happening? Let's talk about this side by side. Okay. We know that the ball was moving down the aisle. So as its speed was increasing, so the resistive force by the oil on the wall was increasing. Okay. So the speed, as the speed or velocity increases, resistance increases. So up till here, we can say like this point 0.03 seconds. Now it's a straight line, so we can say that the resistance increases to a moment when it's equal to the weight. So when the resistive force is equal to the weight, it means that there is no resultant force acting on the ball. So now if there is no resultant force acting on the ball, the acceleration is 0. So then at approximately 0.03 seconds, not necessary to mention, acceleration decreases to 0. When this is a straight line for a velocity time graph, we can say that this is the terminal velocity achieved here. And terminal velocity achieved at a point when all the forces acting on the objects are balanced. Okay, so terminal velocity is achieved here. Right. By trying a tangent on figure 1.2, determine a value for the acceleration of the ball at t is equal to 0.010 seconds. Okay, so the question is for 3 marks, and he says draw a tangent on the figure at 0.010. Okay, first of all, locate this point, right? So you need to locate this point first of all here, like this is the point. Okay, right? So what we need to do, we need to put a straight line here that is just touching it. Okay, because this is a part of a circle, so you need to put a straight line here, right? By using a scale, you need to find out a straight line, okay, that is just touching the path of the circle here at this point. So that's the tangent, okay. We can locate its points anywhere, any 2 points you can locate. For example, let me take these 2 points, okay. One point is here, okay, and the other point, let me take this point, right. So my points are here, x1 is 0, y1 is 0.02. At this point, if I try to figure it out, 0.02, 0.04, 10 boxes, so that becomes 8, 0.02 is, that is 0.036. Okay, so this point becomes 0.01 and 0.036, right. So how to take the tangent? We know that that is y2 minus y1 by x2 minus x1, and it will give you 0.036. Okay, let me solve it there as we have the points. So y2 minus y1 by x2 minus x1, that's the basically tangent here. So that was, on y-axis we have this, on x-axis we have this, so this becomes acceleration. So that value was 0.036 minus, what is y1, that is 0.02. So x2 was 0.01, we located at the same point, and that was 0. So on calculating, we'll get this value as 1.6 meter per second square. So by using this word command statement, you have to draw it, okay, then use this formula and get the final answer, then and only you will be able to score full 3 marks, okay. Right, moving towards question number 2. Figure 2.1 shows two identical trolleys P and Q held at rest on a frictionless horizontal surface. A load is fixed to trolley P, okay, that is a load 1.5 kg. There is a compressed spring between the trolleys P and Q, okay, there's a compressed spring here. The trolleys are released as the spring expand, it pushes the trolleys apart. Trolley Q moves to the right this way at a constant speed of 0.36 meter per second. Okay, speed is here. The mass of each trolley is 1.2 kg. Okay, all right, everyone has a mass of 1.2 kg. Okay, this seems to be a momentum question. Okay, the mass of each trolley is 1.2 kg. The mass of the load on trolley P is 1.5 kg. Okay, it was already given. The spring has negligible mass. Calculate the speed at which velocity, sorry, the trolley P moves to the left. So we have to find out the velocity of this trolley. Okay, that's a very simple question from the law of conservation of momentum. And we know that the total momentum, uh, you know, before the collision is equal to total momentum after the collision. But here we are just talking about releasing the spring. So the total momentum should be the same. Okay, we can say that the total momentum represented by P of a trolley P is equals to total momentum of Q, trolley Q. Okay, so by putting the values, we see that MP Vp is equals to MQ VQ, right? We have to find out Vp, so we'll rearrange the equation as Vp is equals to MQ VQ by MP. Just substitute the values here, you'll get the final answer. MQ was 1.2, VQ was 0.36, and MP was the total mass. Okay, that is 1.2 plus 1.5, that is 2.7. So you'll get its speed as 0.16 meter per second, right? The kinetic energy of trolley Q when it moves at 0.36 meter per second. Just need to find out the kinetic energy of this. We need to remember the formula. that is 1 by 2 mv square. What is the mass of a trolley Q? That was 1.2. What is speed? Speed is given as 0.36 meter per second. Take the square here, and you will get, on simplifying this all, you will get 0.078 energy joule. Okay. State the energy transfer that takes place as the spring expands. So when it was compressed, it was having elastic potential energy. Okay, so when it expands, we saw that the trolleys are moving on both sides. So this energy, elastic potential energy of spring, is converted into kinetic energy of trolleys. All right, this part contains 1 mark, this part contains the second mark. Question number 3. Figure 3.1 shows a small block of ice floating in a beaker of warm water. Okay, there's a block of ice, and that's the warm water. State one way in which the motion of the particles in ice, differ from the motion of particles in water. We know that the particles of ice, they are in solid form, so they vibrate only. And for the water, they move throughout the liquid. Okay, write any one of the statement, you'll get the mark. Energy is transferred from the water to the block of ice. Okay, energy is being transferred now. Okay, so we know that there are 3 ways to transfer energy: conduction, convection, radiation. So conduction and convection, you have to pick from one of these. Okay, state the name of the thermal process that transfer energy from the water to the ice. Normally, most of the students, they get confused here that, okay, the particles of water move throughout the liquid, so convection is the right answer here, which is not the right answer. The energy transfer from water to the ice. How energy being transferred from water to the ice? Being getting contact. Okay, so when there is a contact, so energy transfer is by conduction. Remember this thing. Right. Initially, there is 0.34 kg of water in the beaker. So mass is given. Specific heat capacity is 4200 joule per kg per degree Celsius. Calculate the energy transfer from the water to, as its temperature decreases from 28 to 10 degrees Celsius. So there's a change in temperature, and that is 18 degrees Celsius, right? You need to find out the energy transfer. Okay, so what is the formula that comes into your mind for energy transfer? That is simply E is equals to mc delta t. It's mc delta t or mc delta theta, whatever you want to like. Just substitute the values: 0.34 into 4200 into 18. On calculating, you'll get the final response as 2.6 10 power 4 joule as its energy. Okay. The temperature of the water near the ice decreases first. Okay. Explain how convection, now you're going to talk about the convection, okay, causes the temperature of all the water in the beaker to decrease. The temperature is decreasing. Okay. We know that it was decreasing from 28 to 10 degrees Celsius. So what is happening? See, all those particles that go back here on the image, the particles that were in contact with the ice, the nearby particles, so their temperature decreases, they become colder or cooler. So when they become cool or cold, so their density increases, they come close together. Okay, their density is increasing. When the density increases, they have to go down. So the denser particle, the cooler particles, when density increases, they go down, and the warmer particle, they move up to take their space. Okay, just convert into wording now. Water near the ice becomes cold, the density increases. These cold particles of water, they sinks, go down, and the warmer water rises and replaces the colder particles. So that's how the convection are forming here. So all 3 marks can be justified easily. Okay. State what happens to the internal energy of the water as the temperature of the water decreases. We know that there is a relation between one of the energy. Internal energy is sum of basically potential energy plus kinetic energy, like the position and the movement of the particles. Here we are just dealing with the movement of particles. Okay. Describe the change in terms of energy of the particles. We have these 2 energies, so we are just going to talk about this. As we know that temperature is decreasing, so the kinetic energy is basically directly proportional to the temperature. As the temperature is decreasing, kinetic energy is decreasing. and if the kinetic energy is decreasing, it means the internal energy is decreasing. Okay, so as the temperature decreases, kinetic energy decreases, like the average kinetic energy of the particle decreases, so the total internal energy of the particle also decreases. Okay, right. Moving toward question number 4. The lens is in a magnifying glass is a converging lens. Or that need to be remembered. Figure 4.1 shows the lens of the magnifying glass, its two focal points f1 and f2 and its principal axis. This line is the principal axis, we know that. That's passing through the center, the optical center of the lens. And that's a distance, a specific distance. Okay, that's fixed for every lens. And that's called the principal focus of the focal point. State what is meant by focal point. Okay, this is the point basically, at which the rays are traveling parallel to the principal axis, and after passing through the lens, they pass it from this point. Okay, the point at which rays of light traveling parallel to the principal axis intersect the principal axis. See, they go from this here. Okay, or whether we revert it, so for the other lens, the diverging lens, they pass from here, that end, and converge after passing through the lens. Okay, so they're going parallel to the principal axis first of all, and then passing through this point. A student using the magnifying glass sees a magnified image. We know that. On figure 4.1, mark a point X on the principal axis for a possible position of object. We know that for using this as a magnifying glass, the object need to be placed in between focal point and optical center. A point E for a possible position of the student's eye. Okay, so we need to look at these 2 points. So one of the points, like if it was represented by X, so X is at that point, and E should be on the other side. Okay, right, this, not exactly here, it must be here. Okay, underline 2 words in the list that describes the image produced in A2 here. Okay, will it be inverted? No. It will be real? No. It will be on the same side, so this will be virtual. Okay, and this will be upright. Yeah. Okay, so the refractive index of the glass used to make the lens is 1.5. The speed of the light in air is 3.010 power 8 meter per second. Calculate the speed of light in the glass. We know that the refractive index is basically the ratio of speed of light in air to the speed of light in the medium. Okay, just rearrange it, put the values, and you will get the answer. That's a very simple question, by the way, here. And you will get 2.0 into 10 power 8 meter per second. We know that the speed always decreases. Okay, state what happened to the wavelength of light as it passes into the lens. As the speed was decreasing, so it means that the wavelength is also decreasing. Okay, so wavelength is decreasing. Converging lenses are used in spectacles classes to correct one problem with vision. State the name of the problem and explain how a converging lens is used to correct it. You may draw a diagram. We know that they are used to correct the long sightedness. Okay, what is happening in the long sightedness? If I may draw a diagram, which I'm not good at exactly, we know that that is the actual lens of the eye. Okay, so the rays that passes through here, they do not focus at the retina. Okay, so they focus behind the retina. So what is happening? So when we are going to use converging lens in front of it, they converge the light rays. Okay, little bit. So now they focus just exactly at the retina, the image here. So what is happening here? So just installing another lens, a converging lens in front of the eye, making the image to move on the lens or on the retina. Okay, here on the retina. The converging lens focuses the image on back of the eye or exactly on the retina. Okay, you just need to write this as well. You may draw a diagram as well. Okay, 1 mark for here and 2 marks here. So this may enhance your answer. If you do not write, you may not be able to put good words here, better words here. So you should draw, something like exactly that may add on to your marks. Question number 5. Describe how a longitudinal wave differs from a transverse wave. That's a very simple question. So students normally remember that the longitudinal wave, the wave is, the particles of the wave are parallel to the direction of traveling of the wave. Um, we have compressions, refractions in it. In transverse wave, the particles vibrate perpendicular to the direction of traveling of the wave, and we have crest and trough in it. Like, the transverse wave is like that. Okay, that's the mean point, and the longitudinal wave is something like that. We have compressions and rarefactions here. Here we have crest and trough. Okay, figure represents a seismic wave produced by an earthquake. State whether this seismic wave is a P wave or S wave. We know that this is a longitudinal wave, so this is a P wave. So this is a P wave as it is a longitudinal wave. Okay. The wave represented in figure has a wavelength of 1.2 10 power 4 meter. Okay, the wavelength from here to the next here. Okay. Calculate the actual distance between point J and K. So we need to find out the distance between this, like this. Okay. So what is this distance basically? It is 1.5 times lambda, the wavelength. Okay, because the wavelength is between two consecutive compressions or two consecutive rarefactions. So this distance is basically 1.5 times lambda, and we are given with the value of lambda. Okay, 1.2 10 power 4 meter. Simplifying it, we'll get 1.8 10 power 4 meter. Okay, the wave in 1 and 2 travels through the ground at a speed of this. Okay, as the wave passes a certain point, the ground completes 5 oscillations. Calculate the time that it takes for the wave to pass and show your working. That's a very important question. Okay, so we know that we have V is equals to f lambda, and we can find out the frequency as V by lambda. We have 4600, and lambda was given as 1.2 into 10 power 4. So we get the frequency as 0.33 hertz. Okay, so there's a relation between frequency and time period. Okay, so the time period is 1 by f, so that is 1 by 0.33 will give you the time for one wave to pass through it. Okay, so actually we are having 5 waves, so we need to find out the time for 5 waves. That is, we can say that is 13 seconds. So the time required to complete 5 oscillations is 13 seconds. All right, so with that we are ending today's paper here. In the next video we will be completing next questions. All right, stay tuned, take care, bye bye.